Alright, so hari ni kita akan main dengan Python. Ini change it. See, nothing happen. Dia random je ni. Python. Aku nak main Python 3.9. Aku rasa dah update lah 3.10. Yeah. So apa aku nak buat? Aku akan buat a nice list. I have a list. So kita akan add 32 benda. Dari tu 64. See. For every I in a range 64. Then append 64. 128. 128 is good. Oh, 64. Boom. Yeah. Alright. So the list of dang has a nice length of 64. Very cool. Now what we're gonna do is grab the memory location of dang. Gonna convert it into a hex because we wanna use it. We wanna go there using cheat engine. Nampak ni dia 00 and stuff. Very cool. Aku tak atas je. Oh my god. Tak. Alright, tepat. Cik dah betul. Kita ada satu kat sini. Kita ada benda ni. Kita ada benda ni. Obviously they divided by 8 bit. 8 byte. 1, 2, 3, 4, 5, 6, 7, 8. Mari kita get 64 bit. What does the number mean? 64. That's the length. Let us start the length. This one is probably just a memory address. This one is probably the reference counter. I do not know if it's true. We're gonna test it out. Tank 2, tank. Oh my god, it is the reference counter. Nice. And I guess this is the very cool length. So if we add to the append and number 64, you wanna see that 40 thing increased by 1. Very cool. Increase by 40 here. And see how it just highlighted 8 of this. Then for this one, I do not know. I guess this means it's the other thing. I mean, that's what I get so far. What's this? There's probably another memory space. And this 4C76, I do not know what does that mean. I wonder. No, actually no. Is it? No. I'm out. This has a very cool structure here. So here's the reference counter, memory, length, another memory, and then a number, then a memory again, and then a number, a memory, a number. If you to follow this pattern, I mean, so this is the reference counter, this is some memory, this is the length of the thing. Then this should be a number for the next variable, but we do not have a variable. So that's very weird. But we should just go to here, I guess. Just to check what is there. 8 40. I don't remember doing anything that's involved 40. And memory, and then there's empty space. What I can do is just do the ID of the tank. I forgot to do the hex thing. $77. Oh, what? Interesting. This one here. I guess this is relatable, I guess. So I don't know, but if we follow the same structure for the dank, this is the reference counter. It's saying there's 977 referencing to that value, to this value, and this is the memory. I do not know what it is. This is the length, and this is the value itself. If that is true, if we go to the dank one, so this is the reference counter, very cool memory, length. This is the one that we're looking for. Okay. Nah, cannot. Just gonna edit this to 8 by 8. The hexadecimal. Let's go over there. Oh, very cool. Look at this. So we see that a nice repeating thing here. So this is the list, the array memory. See what's the length of the dang right now? 5. So dang 64 is equal to something else. So 1. Oh, it's changed. Yep. Now this is pointing to the 1 memory. Change right to 64, it will go back to the memory that holds 64. Very cool, very cool. What we can do from this? Not much actually. What can I do from this? See, if you go to the list.pen, I'll actually just do dang.pen. You will get a nice address list here. Is it the same as this one? F1 800 6A 77 F1F. Yeah, it's the same. I wonder what's more can we find. Badabam. Oh wait, it's actually not all the same. Wait a second. Dang. That should be the same, right? Same. Just go there again. This is the reference counter. What? And then nice lang. This is the thing. What's this again? 6. I don't know what that means. Let's go to address. One of 76. Yeah, that's where I wanna go. No, I do not want to go there. Wait, what? I don't know. Okay, it's the same. Yeah, the same. I wonder what happens if I just do the dang dot pop. I guess it doesn't remove it. Oh. So what's this does? I'm gonna do a nice accessories. Remove this. What's gonna happen? What's gonna happen? Do 63. Say index is out of range. I guess it's coming from the length thing. Dang. I'm just gonna remove everything here. Dang pen 5. There you go. So really pop 2 times, 3 times, I think. Pop, and then it's rewrite. If there's a new value, we're gonna write here. Nice. That just mean we do not need to zero out when we pop. We just need to move the pointer. Mom. What's more to see? So Python has a module called array. Because as you can see from here, if you want to access the value of the list, say at index 0, first you will have to grab this from the pointer. I'm gonna walk through this. So let's get there. No, actually you can just grab from here. So what Python gonna do is gonna go to this address and then grab this address. So from this you're gonna plus until this become 18, and then dereference this. Okay, so I'm gonna do this for 8 byte and then it's gonna go dereference like this, and then say we want to access the index 0. What we want to do is gonna once again grab this address and dereference it again, and then the value will be at here. This is the value that we're looking for. That is how much jump you need to do. That's a lot, right? So there's this thing in the Python module called array. So I do not know what it is. I've never checked it before. So what we're gonna do, we're gonna import array. So you can see here, really cool, have minimum size bytes, notes here, probably, what's going to be 16? Oh, the white char. Alright, the white character. The following type codes are defined. Is it bits, right? It's bits, okay. And take 2 bytes or 4. So we have this. The actual representation of values remember the machine architecture. So what we're gonna do here, as you can see, array type code with an initializer. What is an initializer? Any array whose item are represented by type code and initialized from optional initial value, which must be a list, a byte-size object, or iteratable of elements to appropriate type. It's easy. I just remember how to do the list comprehension. So the type code is a nice char here. It's a string basically. A float. Yeah, it's gonna do a double. Now actually let's do a long sign. Should we do sign? Should do sign one. Boom. So for every I in the range. No, actually, let's do 64. Nah, we can see it. Let's do 128. It's not gonna overflow anything. 512. For every I in a range. 64 is enough. That's good. Oh, I forgot to do this. Alright, so nice. Nice is an array. So what I'm gonna do is locate that thing. See what object can we get? Get a pen. How do you do that? Oh wait, it's not predetermined, is it? Ah, I forgot. Buffer info. Let's get this. Buffer info seems to contain something very cool. Array.buffer. Oh, I forgot. It's supposed to be nice. Nice. Okay, this sucks. So I have the nice address here. There you go. It's supposed to be this one. I put it as long. I'll use 8 byte. Whoa, what happened here? Does it even use 8 byte? I think it uses 8 byte now. Oh my god, I've been scammed. I've been scammed before. Oh my life. Wait, an integer use 2? What the shit? That's 16 bits. What the heck? I've been scammed. Whatever. So now I have a 4 byte thing. You can edit this in a 4 byte mode. Change it into something like 1204. And then when we call the Very cool. What does it call again? Nice. We've changed the value here as well. And let's see what Python has to do here again. Has ID of nice. What? Isn't that the... Isn't this the... Oh, okay, no, it's not. Okay. So the reference counter, some memory, length, I guess. How much? 64. Dude, this 64, right? Yeah. Isn't this what it's supposed to say in the length there? So right then, and this is the supposed to be the buffer info. T1C 90. Yeah, this is it. This is it. So Python will just grab the address of this guy, and then plus until here, then dereference this. Just quickly copy this, boom, and immediately grab the thing. Very cool, very cool. So array is much faster than using lists. But the thing is, I do not know how it grows the... How does it grow the array? Let's do a very quick. Python with the name. If the array is an array, must have the same. If not, byte swap. Byte swap. Swap. Insert. Array.insert. Pop. Have pop here. List. 2 bytes. Invoice. This is it's nothing. Isn't this the... Oh, this is the edge. Oh. I do not know anything. Let's go.